You're listening to Spill the Sea with Ashwati Ramesh.
Hi, Tarun.
Yeah, Shruti.
So glad to have you on. Finally.
Yeah, I know after a lot of rescheduling, so I'm glad to be here. Thank you so much
No,
for
excited
having me.
to, of course, excited to speak with you. I know you're working on the material innovation space in a sector that's only, I guess, recently picking up attention and interest, which is the built environment sector. Um, I'd love to get into, what you guys do exactly, but just before that, quick shout out to the studio that's hosting us. Lovely space. It's a plant-based cafe called Copper and Cloves, and we've been hosting all our wonderful conversations here.
Yeah, I mean, shout out to you guys too.
Also keeps us caffeinated, so
Yeah, also keeps us caffeinated. Yes.
awesome. So let's jump in, maybe to set the context for the conversation. We'll obviously dive into details a little later. What exactly do you guys do?
Yeah, so we have a very lofty goal. We want to remove 10% of global CO2 emissions, and we feel like the best way to achieve that target is by fixing the materials with which we make our buildings. So we're in the business of creating carbon negative concrete based products without using any cement.
Right.
So we're a deep material science company that's specifically targeting the most commonly used materials in construction.
Amazing. I think it's also something that people generally glaze over, right? We
I know.
live in buildings, we work in buildings, we don't think twice about it.
Yeah,
We think about transport. Transport is much more talked about than this right
I
now.
know.
But excited to see what you guys are doing and hear more about what your solution is. But let's rewind a little.
Sure.
Why don't you tell us, what your journey has been before founding Green Jams?
There hasn't been much of a journey really, than it being my life story.
Yeah.
I haven't ever worked before. I never did a job. I've done multiple internships. I did gain access to a lot of exposure to construction, primarily because I come from a family of civil engineers.
Right.
I'm a civil engineer. My dad's a civil engineer. My granddad's a civil engineer. And in fact, I mean, I'm sure I go back to my ancestors. I would definitely
The
find
lineage
someone
is
in.
similar.
Yeah, it is, and I like my ancestral home. While we don't own it anymore, to my absolute
Dismay.
dismay. I I grew up in a home which had like a meter thick walls made entirely with lime and bricks sourced on the site,
Right.
made on site, and then it was a beautiful
Right.
old building. And from that to when I was finishing my engineering, the sort of buildings that I saw that were coming up. In fact, Brigade Lakefront was my last internship, which was when I decided that I am not going to be doing what conventional civil engineers do.
Right.
I am going to uh, break out of this mold that I've been cast into through
Yeah.
all of my years of training, and decided to sort of challenge how building materials are thought of, challenge the chemistry, try and figure out alternative ways of decarbonizing concrete entirely.
Right. Right. And I guess you've spent quite a bit of time. You've been learning and working with building materials right from the start, right?
Yeah.
How did you maybe stumble upon this particular aspect of it?
Yeah, I mean, Varun and I are brothers. Like we grew up together, come from the
Oh,
same
right,
womb.
right, yeah.
So, I mean, that's how I know him. And originally, when we actually started the company, the idea was to bootstrap it. So it was just the four of us, mom, dad, Varun, and I, that
Right.
we set up the company. And we thought, well, let's use the family money and then grow the business. And I'm sure that's going to bring us a lot of returns. And
Yeah.
super naive, right? We thought we'll taste success on the first day of starting the factory.
Yeah.
Obviously, that didn't happen. It took a lot of struggle. We incorporated the company in 2019.
Right.
And my journey before 2019 was at least 5 years. So I
Right.
spent a lot of time learning about bioconcrete and hempcrete, and in fact, hempcrete was the first material that I started working with.
Okay.
And towards the end of college was when I stumbled upon hempcrete,
Right.
and I was so fascinated that you could make a building material out of something that you could smoke, and um, and that was the sort of like the eureka moment for me.
Yeah.
And when I
You worked on that for quite a bit, right?
I
That-
did, yes.
Yeah.
So the whole base for what Agrocrete is today was all the years that I spent on learning and developing hempcrete for India.
Right.
So when I learned about hempcrete, I fell in love. Obviously, the first mistake that an entrepreneur ever commits is falling in love with their product. That's the first thing that I did, and I went down that path. I guess I wasn't an entrepreneur back then. I wanted only to be an innovator.
Right.
And when I started learning more about it, studying it, I realized that one, there's a lot of myth around hempcrete, and second,
What do you mean?
um, myth in the sense that when you, so this is 14 years ago,
Right.
if you were to type hempcrete on Google, you would hit a few web pages that would talk about how hempcrete is 20 times or 20 times stronger than concrete, and
Right.
about less than, I mean, almost 10% the weight of conventional cement concrete and all of that stuff.
Right.
It's not true. Hempcrete at that point in time was one of the weakest materials that you could use. And it was predominantly used in Europe and the northern part of the global north, primarily because it's a cold region
Yeah.
and you need insulation, and that's what hempcrete was traditionally used for. It's
Right.
not that it's carrying any loads of your
Right,
beams,
right.
columns, slabs, and stuff. So, and that wasn't something that we could directly bring to India and then have people accept. And this is something that I learned over a duration of time, that the decision makers are never your home builders or the owners of a home, right? It's always going to be the mason, it's always going to be the contractor, it's always going to be the engineer. A lay person who wants to build their own homes will not be qualified enough to make the decision
Yeah.
on what materials to use.
Yeah.
So that meant that that meant that I had to develop hempcrete for India, understand the science behind it, understand the chemistry behind it, fix the issues, figure out ways where hempcrete could become as strong as conventional burnt clay bricks or concrete blocks or whatever was selling at
Right.
that point of time. And that's when I started. I enrolled for a master's. I did a master's in environmental forensics from National Forensic Sciences University. Um, the most underrated university, if you were to ask
Really?
me. It's fantastic. The kind of access that I had to labs, equipment, brand new, well maintained.
Nice.
That's when I got really into the deeper side of science.
Yeah.
The first research paper that I wrote, I didn't expect that research paper to actually gather so much attention.
Right.
And that's when I realized that maybe I'm on the right track. Somehow convinced my dad to let me go down this rabbit hole,
Yeah.
and then create a newer product, right? And the idea that I might also in the process earn a PhD while creating this new product
Yeah.
was quite exciting to my father.
Right.
And but obviously, I mean, I had different plans.
But you did do your PhD in.
I did.
Yeah.
I did. I enrolled for the PhD and then quickly did the product development. Hempcrete happened. In fact, while it's not validated or substantiated anywhere, but from the pure technical spec sheets, you would realize that hempcrete that I created was the world's strongest.
Right.
And that's when I wanted to go to market, and then the market catches up, right? And this is the first time that I'm wearing the hat of an entrepreneur, trying to figure out how to go to market with this product that I created, that I have fallen in love with.
Yeah.
Yeah.
And this you were doing on your own.
This I was doing on my own. Yeah. Until now, like until this stage, it was a completely solo journey.
Yeah.
And then I set up, and then I started talking to people. I tried to start sourcing hemp and
Right.
hemp stocks basically, and that's when I realized that, man, this space is crazy. Like you do not, there's so much gray area. I was convinced that the other companies that were working on hemp by then would have established an ecosystem through which we can source hemp, but that did not happen.
Still disorganized.
Yeah, still disorganized. The kind of pricing that these other hemp companies wanted was insanely high. It
Right.
wasn't viable. It wasn't making sense. And all of a sudden, I'm sitting there wondering, okay, I've poured in all of my
Time and effort.
time, effort, and just my soul into it.
Yeah.
And then suddenly there's nothing I can do with it. What am I going to do with this? And while I'm in this dilemma was when I was when winter came along of 2018.
Right.
And that's when Roorkee, Delhi, the surrounding areas, all the fields surrounding these regions were set ablaze, and then all of a sudden there's so much smoke and smog, and I never had asthma, but I started having difficulty breathing, and
Yeah.
my rhinitis, which was gone for a very long time, suddenly came back with a vengeance, and I was like,
Yeah.
what the hell is happening? And around the same time was when a few newspaper articles came out, which were attributing this stubble burning with rhinitis and
Yeah.
bronchial issues and stuff. So I was like, interesting. Now there might be an alternative to hemp that we can start working on. And then again, that was the second Eureka moment. And then I started replacing hemp with paddy straw.
Right.
And I started learning more about the stubble burning issue, right? And it's crazy. I mean, people think that this happens only in the northern part of India, but it's across.
Yeah.
MP, Orissa, West Bengal, Andhra, Karnataka, Tamil Nadu, like all of these regions have stubble burning issues, right? But just because these are not hill locked,
Yeah. The geographical
correct.
advantage, basically.
Exactly. And second, like for some reason, these regions do not have a lot of AQI monitors.
Right.
So all this flies under the radar. Like I come from Vizag, and Vizag is one of the most polluted cities in India. But did you know that the Pollution Control Board has the authority to
Hide numbers.
denotify privately examined air quality metrics?
Right.
Yeah, so they can easily disqualify whatever as a in case you're a private body that's trying to monitor air quality.
Yeah.
Those results can be disqualified by the PCB.
Right.
So it's never taken into national record, right? So and anyway, but there are all of these fundamental issues that exist in the country. And when I started learning about this, jute stock is burnt, cotton stock is burnt. Paddy also started burning in the Godavari plains of Andhra. So this is a massive problem.
Yeah.
And then I replaced this, and all of a sudden I ended up with a product that was much better than the original hempcrete that I created. And I
Right.
was like, crazy. This is something that we can go to market with. I called up my brother. He was just finishing law school. And I told him that, dude, I think we've created something. Let's go to market.
Yeah.
And that's when we incorporated the company. Simultaneously, the work that I was doing on hempcrete got recognized by Forbes, and we were on Forbes 30 under 30.
Yeah.
Asia, and all of those things happened. And suddenly I realized that,
Yeah, I did see those articles
oh yeah,
during research.
nice. So yeah, that was basically the backstory for how
Right,
Agrocrete
right.
happened.
Wonderful. All right. So, Tarun, maybe let's zoom out now a little bit and talk about the industry itself. What are generally the materials that are being used right now? What's been the evolution? And yeah, I guess what are some of the challenges here, and what is the industry struggling with?
Got it.
Yeah, that was a big question, but you can split it into parts. And
That's what I was thinking about. I mean, I was just
Yeah.
figuring out ways in which I could split it down. So, from a let's look at the life cycle of a building, right? How it starts to the end of, by the time you occupy it and then use it, and then it goes into demolition. So you start with concrete first. That's the most used line item in the BOQ, bill of quantities, of any building. Second comes steel,
Right.
and third comes your bricks. So together, these three, by mass and by volume, are the most used materials in any building. And then come your flooring, then the plaster and the mortars and the
Yeah.
paints and the finishes, your walling finishes, and then from a cost perspective, one of the most again used materials are glass. For
Yeah.
your fenestrations, I mean, for your doors, windows,
Yeah.
and frames. Aluminium is another big contributor to cost, as well as the embodied carbon
Emission.
of a building.
Do you
So-
want to maybe also, since you mentioned it, elaborate on the embodied carbon component of a building?
Yeah, for sure. So embodied carbon simply means during the life cycle of a material, from extraction of raw materials
Yeah.
to the energy consumed in transforming these raw materials to the final product, and after the final product is made, the transportation to the site where it is being used. So at each of these stages, you end up creating GHG emissions, and the sum of all the GHG emissions coming from each of these stages is expressed as an equivalent to CO2.
Sure.
So that is basically the embodied carbon of any material. So it simply means, when I say that cement has an embodied carbon of 900 kgs of CO2 per metric ton, it simply means that to produce 1 ton of cement, we emitted 900 kilograms of carbon dioxide.
Got it.
So, and what we are targeting from a company perspective, the sort of the materials that we are trying to replace are concrete
Okay.
and bricks.
Okay.
And soon we will also start doing your flooring finishes,
Oh,
your
interesting.
walling finishes. We're getting into replacing entire RCC itself with
Right.
Agrocrete. So those are things that we're going to work towards in the future.
Future, right.
Um,
Exciting.
Fundamentally, what we're targeting here is, when you look at concrete in itself, the 80% of all the emissions that come from concrete, in a few cases up to 90% of all the emissions that come from concrete, is from cement alone. So you fix cement, you magically fix the entire built environment.
Right. Tarun, you've spent more than a decade in this space, right? How have you seen this industry evolve? I guess maybe more also on the perception shift. Are builders, developers more open, interested?
Yeah.
I know it's a price sensitive market, but what are your thoughts on how this shift has been moving along?
To say that construction is a price sensitive market, I think is incorrect.
Okay.
It's not that price sensitive, because we've seen in so many years of me running this company as an entrepreneur, as a founder, trying to sell our products to builders, what we've realized is it's not price sensitive, it's trust deficient.
Okay.
So if you're able to build trust with the market, it's automatically going to respond with rewards, which is
Right.
even if you're going to price your product higher than 20% higher than what is incumbent, people are still going to come and buy.
Right.
But because we haven't, or majority of the construction material companies in India have not been able to build that trust with the market, it's a two-way street. Why trust does not get built is also because, especially when you're introducing a newer material to the market, it involves a certain scientific and technical rigor to be able to evaluate it and then apply it in your buildings.
Sure.
So generally, a lot of times what happens is, one, especially because it's a new material, automatically, through no fault of theirs, automatically they end up wearing the lens of a skeptic.
Yeah.
So, and then, which means that you're starting below zero, right? You're at potentially -1.
Yeah.
And from there you build up to zero, saying that chalo theek hai, now I am okay to use it, but I'm still indifferent to the product. And from there you build it up to 1, and then all the way to 10, where 1 is okay, I think I like the product. 10 is where, dude, you have to use this.
Right.
So that's where we end up starting for any construction material company. When I say that technical rigor does not exist in this country, it's primarily because even when you look at civil engineering as a subject which is being taught in your colleges, take simply the case of concrete technology.
Okay.
It's almost like an open book exam.
Really?
Yeah. So the questions that you get are essentially, say, for example, they give you details of what kind of sand,
Sure.
what kind of stone chips, what kind of cement, and they say design M40 mix.
Okay.
And then they give you the code book.
Right.
So all you have to do is apply some common sense, go to the correct page number on the code book, and then just do those calculations, and then you get
Right.
100 on 100.
Right.
And that's also one of the reasons why I have 100 on 100 in concrete technology in college. I guess I just knew how to use the damn code book. So it's mostly just codes and guidelines driven. So no
Right.
one's really going out there and trying to understand the product's chemistry,
Yeah.
why you use a certain steel dimension, why you use a certain length, and why the different aspects of the buildings that are taken into consideration.
Sure.
So, which is one of the reasons why this appears to be a price sensitive market, especially when someone wants to reject you. Because
the
they
reason
haven't
they
been able
use-
to understand all of these things, they simply say
Right.
that, hey, you're too expensive.
But isn't it, I would still think that it's maybe companies with slightly higher budgets to cover that premium where it's not going to be that sensitive, right?
Yeah, for sure. So I'm not saying that
Yeah.
everyone is not
Sure,
price
no,
sensitive.
I understand
Of course,
where
there are
you're
going to be
coming
price
from.
sensitive people, right? I mean, and you have buildings being made from people coming from different social strata, especially for the rehabilitation projects, slum rehabilitation, redevelopment projects, where you have to build alternative housing for slum dwellers. Those are some of the least expensive projects. So that's where cost is king.
Right.
And that's where you start seeing substandard use of materials. So the quickest way to essentially make a really large development with at the fastest pace to ensure that you're able to rehabilitate, rehouse these slum dwellers is by just pouring concrete for everything.
Yeah.
And those homes you cannot live inside. There are not sufficient windows, there's not sufficient light, there's not sufficient ventilation.
Yeah.
And on top of that, because they're made with concrete, the walls are extremely thin.
Right.
It means that all the noise from the outside is coming in, all the heat from outside is coming in, all the cold from outside is coming in. And it's also become extremely carbon intensive because it's all made with concrete and steel.
Yeah.
And these guys end up putting eventually air conditioning. And interestingly, while they were living in a slum, they did not need it. And now that they've come to an alternative housing, now they suddenly need air conditioners and desert coolers and energy guzzlers.
Yes.
So yeah, those sort of markets essentially are extremely price sensitive. But for the major part where it is becoming more organized, like for example the likes of Prestige, Brigade, like I apologize for taking names at this point, but they're amongst one of the largest consumers of concrete for their buildings, right? Like for example, Prestige is developing, I'm not sure, hundreds of villas near Nandi Hills, and they're simply pouring concrete for everything. You have
Right.
this huge mold of a house that they just assemble and they pour concrete for everything and then they move to the next one. So the
Right.
pace of construction has increased rapidly,
Hmm.
but the cost actually has gone up. They're
Right.
paying approximately 15 to 20% higher than what it would have been if it was a brick and block based
Right.
construction,
Right.
as opposed to just pouring concrete in what they're doing right now.
Has it shifted drastically since you started working in this space, or is the
I mean, drastic shifts don't occur in this industry. It's extremely slow and methodical.
right?
But yeah, I think there has been a drastic increase in awareness about
Right.
sustainability,
Yeah.
alternative materials. And I think the biggest driver for this is coming from the finance industry. So, I mean, your international funders, European institutions that are pumping billions of dollars into India through financial institutions, they all are demanding.
Okay, so investor pressure basically.
Correct.
Got it. All right, so maybe now coming back to the product itself, Agrocrete.
Yeah.
Um, I know you've already told us about it, but you've also mentioned some of the byproducts that you're using. But could you share a little more on how you're actually making the product?
Yeah, for sure. Agrocrete is majorly made of three classes of materials. The
Okay.
first are your agricultural residues.
Right.
So these include, we're agnostic with the kind of residues that we use. So these include paddy straw, bagasse, cotton stalks, corn stalks, jute stalks, hemp.
And anything goes.
I mean, anything which is fibrous, which is essentially a stalk of a plant, which is harvested or thrown away, discarded after harvest, is something that we consume. In fact, we've also recently started incorporating biochar into our mixes.
Okay, interesting.
So that's the first set of ingredients. The second class of ingredients are the fillers.
Okay.
In any concrete, like your sand and the stone chips, they're essentially fillers.
Right.
So we use a combination of fillers. We're using reclaimed excavation soil. It's crazy. Like some of these buildings that are made, which go really tall,
Yeah.
they end up digging huge amounts of soil, and there's no accountability for where it's going and getting dumped.
Right.
So we've become a big conduit for a few of these projects, at least, where we're able to consume a lot of their soil.
Okay.
Second include byproducts coming from the quarrying industry, marble, granite, limestone.
Yeah.
They're used for your floorings and finishes and so on. But for every metric ton on average of finished product that you get, almost 1.2 metric tons of the stone waste is created.
Oh, wow.
So it's a huge waste.
Right.
I'll also send you some images of how quota stone mining is done. You literally go almost 30 meters underground.
Right.
And when you look at the strata from which you're extracting quota stone and the amount that you have to dig before you reach it, tree looks like an ant. A fully grown tree looks like an ant in grand scale. So again, billions of tons of waste currently available in India, which are in landfills and sites that have already created ecological havoc, biodiversity loss, and so on. And finally, you have the fly ash. You have different types of slags and byproducts that come from ceramics is another huge contributor to waste.
Yeah.
So all of that are the fillers that go into it. And the third most important component of any concrete is the cement. In our case, because we don't use cement, I end up, through this whole R&D process and everything, I ended up inventing our own cement. So it's from the slags of the iron and steel industry.
Okay.
Slag is a byproduct when you melt steel.
Right.
So that comes from the crucible liners and everything put together. It's a mineral waste that comes out.
Yeah.
We use 4 different types of slags that come from the iron and steel industry. We grind it, we activate it, and then we mix it together like conventional cement concrete.
Right. I do want to maybe touch upon some things. So your first category was agri byproducts, right? So, I mean, something that I guess I've always thought about, the reason that this whole stubble burning process happens is because I guess the farmers, it's the easiest way for them to get rid of it, right? How are you, I guess, convincing them to give it to you instead?
So I'm not convincing them to do anything. I'm just creating value for it. And
Right.
we're actually, I think, the highest payers for crop residues.
Okay.
And it just becomes a lot more attractive for them.
Sure, if there's a price component which is attractive to them, then it definitely makes sense.
And I mean, like very humbly, we've been able to increase income by almost 25%, in a few cases up to 30%, for
Okay.
almost 150 smallholder farmers.
Amazing.
And generally, working with smallholder farmers is much easier because they're willing to, put in that extra effort to just collect all the crop residues and transport it to us.
Yeah.
So we've been able to make that happen for them.
Awesome.
So, like off late, this is becoming a bit of a trend where we definitely see that developers are accessing a set of customers that actually start asking them questions about sustainability, and the awareness has gone a little bit deeper.
Yeah.
Previously, it was more about, what sort of appliances are you giving us,
Sure.
to now going into the details of what sort of materials you're using.
Yeah.
So we've seen like pretty established developers right now that have started marketing the sort of materials that they're using. And because they're marketing it, they're obviously also able to command a significant price premium on top of everything.
Yeah. Yeah.
And I think that's working fantastically in their favor also.
Right. And maybe, I guess, coming back, you do say carbon negative material. How does that, what do you mean by that, and how does that really work?
So carbon negative means simply, previously we spoke about how embodied carbon means how much you are emitting. Carbon negative means how much you are capturing.
Yeah.
So Agrocrete, because uses crop residues, how we're capturing carbon dioxide happens outside the system.
Okay.
Which means that your raw materials are already carbon negative. So when a plant is growing, it absorbs CO2 through photosynthesis, and that's how it makes its own body.
Yeah.
And once your plant is harvested, that body of the plant, the stalks of the plant, are essentially pure carbon dioxide in a tangible, like physical form.
Yeah.
And out here, I'm wondering why there are so many companies that are just trying to capture gaseous CO2, which is really difficult to capture in the first place, and then
Yeah.
scrub them through expensive chemical processes, and then dedicate resources to it, and then turn it into a mineral or maybe some other form that you can transport the CO2 in, and then dump it deep into the depths of the earth.
Yeah.
That does not make sense for me, especially when you have such a huge resource. You're already growing plants for food, and all of that harvest is in the traditional setup is basically decomposing, and all that CO2 is going back into the atmosphere.
Yeah.
Like, why we're not using tangible physical forms of CO2 that you can lock away forever through alternative means? And nature already does this.
Yeah.
Fossils,
Yeah.
which form under tremendous heat and pressure, or an alkaline reaction, which is what happens in the oceans. So what we do is basically alkaline fossilization of plant bodies.
Yeah.
So
Interesting way to put it.
yeah. So once the plant comes to us, it's already dead, and it's just
Yeah.
fiber. It's physical CO2, carbon basically, which we then mix with our binder, and then that CO2, which had formed the plant body, remains inside the matrix
Right.
because of this alkaline fossilization of the biomass.
Got it.
So in this process, because the plant already has absorbed CO2, has captured CO2, we're actually able to capture more carbon dioxide than we're emitting throughout the entire manufacturing process.
Right.
And that's essentially how you achieve a negative number on the
Right.
on the
Right.
balance sheet.
Makes sense. And what about the actual product in terms of functionality and I guess performance compared to the traditional materials that we use?
Yeah, I mean, uh, unfortunately for us, but fortunately for cement, it enjoys several centuries of vintage, which means that it's been under development for several
Sure. Yeah.
centuries. Um, we are still trying to uh, perfect this in many ways, make it seamless for construction engineers and the overall industry professionals to make it a lot more easy to adopt our materials. Um, so, which means that there aren't a lot of applications at this point for which we can go confidently say that, hey, I mean, blindly, just how you use cement, you can just use our product the same way. We cannot do
Yeah.
that at this point, which means that there's a bit of stewardship that we do. You know, the more number of engineers that we interact with, the more number of professionals that we interact with, we get a lot of feedback from them on how
Yeah.
the product is behaving in their context and how it is that we can improve it further. Which is why at this point we're only doing bricks and blocks because
Okay.
that's something that we've been able to perfect, because that's something where we've been able to achieve repeatability. We've done 1,000 days
Right.
of manufacturing.
Okay.
So now we're
Amazing.
ready for whatever would come our way when we have to produce bricks and blocks.
Right.
In fact, for the first time, when we commissioned the plant in Mysore for this project, we were able to produce blocks on the first day.
Okay.
First attempt. Like we set up the plant, we started the machine, we got perfect blocks out.
Amazing.
Which means that now that knowledge, that experience is inherent,
Yeah.
and a similar skill and muscle needs to be built for the other products also.
Right. Right.
Which means that there's a multi-generational play.
Yeah. And I guess maybe do you have your own plant right now?
Yeah.
And is that where you produce all of your products, or you are you have other outsourced manufacturers in place as well? How is that working currently?
Not at this point. We don't have any outsourced manufacturing at this point, or at least nothing which is very consistent.
Right.
There are some like small orders that we're fulfilling through outsourced manufacturing. Not a lot, 100, 200 blocks.
Okay.
Just to test the waters and understand, how third-party manufacturers would react
Right.
to producing our blocks. So at this point, it's predominantly cocoa, but we don't want to go down that path, which means primarily because we would then be bogged down by huge manufacturing responsibilities, limited scale. It would make sense for us to outsource manufacturing.
Yeah.
There are a
Yeah.
lot of
Exactly.
folks here in the market who know how to make good quality blocks. We don't have to do all of it ourselves.
Yeah. The infra is already established pretty much.
Yeah. There are thousands of block manufacturers.
Yeah. Yeah. I'm sure.
And almost all of them have unutilized capacity.
Yeah. But how much is there a capex element to it, or they don't really have to do much for
Nothing.
yours?
Existing infrastructure, just replace the materials,
Okay.
you get the blocks out.
Okay. So then it's a no-brainer.
Yeah.
All right. So Tarun, maybe to, I guess, shift gears and come to the other side of things, which is your customers. Who are the typical segments that you're targeting?
I mean, ideally, we want everyone to use it, but realistically, that's not going to happen. Which means that the easiest for us to target are the more learned, well-researched audience, right? And
For the initial validation bit, adoption bit.
yeah, early adopters, basically.
Yeah, yeah.
And early adopters have a few interesting characteristics. They generally don't want to do what everyone else is doing, simply because they have that innate desire to stand out of
Yeah.
the norm. And second, which means that they end up doing a lot of research. They are focused on sustainability, and they want a better product for them and their family members and the next generations also. Which means that for the sustainability focus, it's mostly the corporates, MNCs that are building their own assets end up using our products. And from the individual house builders market, it's
Right.
usually the HNIs,
Yeah.
people with wealth that are trying to build their own homes because that's what would give them that additional social validation and
Yeah.
discretion that they can brag about to their friends and to their network.
Yeah.
Which means that it's a great way for us to be able to build word of mouth
Yeah.
marketing for ourselves. So these are the sort of customers that we're initially targeting. But eventually, I see that again, going back to, it's a price sensitive market. No, it's a value driven market. So if you're able to deliver 2x value for 20% increase in cost, it's a no brainer for 90% of the market.
Right.
Eventually, we will get to that point through potentially doing policy related work, build additional awareness campaigns, do more government projects,
Right.
not for the revenue but for validation.
Sure. And what about pricing, since you mentioned it?
Yeah.
How does it compare, I guess, to the traditional
I
material?
mean, when I said 20%, it was all hypothetical. In fact, we're only 10% more expensive than
Okay.
conventional materials.
Right.
But total cost of construction turns out to be about 30% lesser than conventional materials. So overall, we're a cheaper, still less expensive alternative to
Yeah.
to most conventional materials,
Right.
and the total cost of ownership reduces
Yeah.
drastically.
Right.
In fact, some buildings that we've supplied Agrocrete blocks to, they don't need air conditioning.
Okay. Nice.
So they made the homes, and then they suddenly realized that they even gave the provisions for the electrical points and everything at the top of the wall. And then they realized that, dude, we don't need an AC in this home anymore.
Yeah.
So 2 summers in, they still haven't installed an air conditioner, which means that, and there's in Vizag, and Vizag is super
Right.
hot.
Yeah, it is. It is. Yeah, that's interesting to see. I know that even myself, when you go into different buildings, you immediately can tell
Yeah.
based on the material. So a lot of people are now, at least the ones who are aware about this, they talk a little bit about earth homes and mud homes, and it's just, I guess it's shifting, right? People are becoming more aware, and hopefully, uh,
Yeah.
it starts coming into design elements right from the start.
Yeah. Oh, for sure. I mean, actually, design is a very
It's a whole other beast.
it is, and it's
Yeah.
one of the uh, biggest drivers for adoption.
Yeah.
And which is why I mean, like most architects, at least the younger ones, they love vernacular architecture for this very reason, that it gives them the freedom to express design in a very different form, make it more artisanal.
Yeah. Yeah.
But that also comes with its own limitations, right? You can't do vernacular for mass housing. Mass housing
Yeah.
requires modularity. Mass housing requires, and not everyone would be able to afford vernacular architecture,
Yeah.
simply because the way of life is changing. Lifestyles are becoming more fast-paced, more urban, if I could put it that way.
Yeah. All right. So I guess you said, I mean, we spent time discussing this. If it's value over price, what are some of the points that come up when you're trying to convince someone to adopt this solution?
Yeah. So generally, they want to understand if it is going to. Most importantly, they want to understand if this is going to perform better than conventional alternatives.
Okay.
And it's a very simple way for us to convey it. We have comparative studies, so we just simply show them the test report. Trained engineers would understand the test report quite immediately. For the untrained folks, we sit down and we explain that, hey, I mean, this is compressive strength. This relates to how strong the material is. Generally, conventional is about 4 MPa. We're able to achieve 8 MPa. It's almost
Right.
2x stronger for just 10% increase.
Yeah.
and you're going to save so much energy. Your generally for about 1 cubic meter of block work, you end up using about, say, if it is 3 bags, here you need only half a bag of cement. Those sort of value conversations is what we have.
Got it. And I think I missed this earlier, but what's the capacity of your plant right now?
So we've been able to increase capacity from the same manufacturing unit.
Okay.
This is through process efficiencies. Um, while we started at around 500 blocks per day, we have now been able to increase it up to 3,000 blocks per day.
All right.
We're also adding additional capacity. So by the end of first quarter, we will be somewhere around 6,000 to 7,000 blocks per day.
Got it. Got it.
So that's sufficient to build about 2,500 square feet
Okay.
in a day.
Nice. Maybe coming to the regulatory side of things now, again, I guess you've seen it longer than anyone else. How have you, or what are your thoughts in terms of what's been happening? Because I know there's a lot of new stuff on the green building side, built environment side that's coming up, right? So, what are your thoughts?
I mean, unfortunately, regulation, I think, is several decades behind. I wouldn't even say years. Because alternative materials have been in development for a very long time. Like some examples. So fly ash bricks are one of the most commonly known alternative building materials that came up in the recent half a century. But otherwise, you also have calcium silicate bricks, and then you have alternative burnt clay but fly ash, and then you have something called fly ash centered blocks. So there have been several innovations that have already come up.
Right.
But there have been challenges in how these alternative materials are defined and the context in which they're defined. Like in the case of CSEB, right, compressed stabilized earth blocks, basically soil mixed with cement and compacted into bricks.
Right.
Simple tech can be deployed everywhere, are similar in performance or better in performance than conventional burnt clay bricks, also look very similar to conventional burnt clay bricks. But the moment you use soil based materials, they're not defined as a pakka home anymore. It's a kacha home.
Right.
And if you're not using RCC beams and slabs, again, it's qualified as it's classified as a kacha home.
Right.
So, and suddenly, like when you do this misclassification of materials, not on the basis of performance and strength and longevity, and simply based on the kind of materials that you're using, our sort of alternative materials are automatically at the disadvantage.
Right.
Because then everyone that are moving from rural to urban and are moving upper in the social strata are moving towards achieving more kacha homes, or going from kacha homes to pakka homes.
Yeah.
Simply means that they have to put RCC regular cement slab
Right.
on their roofs. And we know that concrete slabs on the roof are not the best for thermal insulation. From a kacha home, suddenly they've come into a pakka home, where in a kacha home they did not need any sort of form of air conditioning or coolers or fans. All of a sudden here, they're not able to sleep under that roof without an AC.
Yeah.
They would rather find a tree somewhere nearby and then go sleep under it. Like utility is going out of the picture, right? So context is missing in conventional in the current regulatory environment.
Right.
And whatever regulation is being brought at this point is voluntary. Like for example, the ECBC code is not a compulsory code that all new buildings have to comply with. It's voluntary. It's a guideline.
Yeah.
So if you make a home according to these guidelines, your energy expenditure is going to be lower and you'll get the star rating.
Right.
That's essentially what it means.
Right.
And second, and the third point is that alternative materials such as ours cannot even become a feature of these codes simply because there are no performance-based standards. Now,
Right.
I can't go out there and get an ISI mark on my product simply because there's no Indian standard which defines in the materials section what raw materials can be used.
Right.
But then, we perform better than all other on all the parameters that are already mentioned in the IS code for a conventional concrete block.
Yeah.
Then why can't I get a ISI mark for myself? Why can't I feature in any of these building codes?
Yeah.
Just being able to mention a material such as ours in a national code would automatically unlock a huge
Right.
market for us.
Right.
So I think that's where the regulatory environment is
Lacking.
lacking, yeah. And like we're notorious for aping all other international standards. Indian standards are simply derivatives of American, British standards, European standards. These three together distilled. We've somehow picked and chosen aspects that would apply to us and then made it part of our standard codes. I'm hoping that we continue aping because now Europe has performance-based standards,
Right.
and we're able to get them in India.
Got it. And I guess we've covered quite a bit. You also talked about what y'all are, the other innovations that y'all are possibly going to have in the next few years. But aside from that, what's the future of GreenJams looking like? Is there anything else that's on the line for you guys?
I mean, from a product perspective, for sure, this is what we're targeting. In fact, we want to replace concrete entirely in a building. So,
Right.
hopefully, in the next 5 years, we're able to make one building made entirely using Agrocrete and Agrocrete-based products,
Amazing.
without using any conventional cement concrete.
Yeah.
We haven't yet figured out a way to replace conventional steel, but there are ways in which we can decarbonize steel quite easily.
Right.
So I think that's how we will do it. But otherwise, yeah, we're on track to hopefully achieving almost 500 crores of revenue by year 5 from today.
Amazing.
So yeah, fingers crossed for that.
Awesome. Good luck to you guys, and looking forward to everything that y'all are working on and seeing it come out. And maybe to close on a more fun note, you've been working as a founder for quite some time. You're also working with your brother. I don't know how that dynamic is when y'all are at work all the time together. But I guess, what are the things you like to do outside of work? How do you maintain sanity in this chaotic life?
One, I mean, Varun's not involved in the business anymore.
Okay.
He moved out last year.
Okay.
But yeah, I mean, like, I've never found myself in a space where I'm losing sanity simply because I very much enjoy what I'm doing. I love my work.
Yeah.
It gives me so much satisfaction and joy when I see our customers using our products, and they're happy.
Yeah. I can see it when you speak as well. The past hour, it just shows.
Yeah.
All right. This was lovely, Tarun. Thank you for being so open about your thoughts and perspectives on the space. Thank you for also sharing. There's so many technical terms and materials that you kind of elaborated on. Obviously, I'll put some resources in the description for everyone who's listening in. And completely enjoyed this conversation. Thank you so much.
Thank you so much.
Thanks for tuning in today. See you next episode.